Hi guys, Mr. Shaw here. Just going through, we got the day 4 agenda going on for physics. Today we're going to pretty much wrap up some of the main parts of the waves curriculum. In particular, talking about the one calculation we have to deal with, and that is basically wave speed, the velocity of it, how fast a wave is going. It's going to be a pretty short presentation. I'm going to go through a couple examples. And then I'm going to send you a online on Google Classroom a quick couple of questions. Just test you out, see how you do. All right, so let's get into it. First one we have right here, so wave speed. This is one of the keys here. Wave speed depends on the medium in which it goes through. So here's the idea. In sound, typically we're moving at a general temperature at sea level, 340 meters a second. But if all of a sudden we change the medium, let's say all of a sudden it gets colder outside, it's going to change the speed that that wave is traveling. So sound actually travels, I believe it's faster in cold. Also, if say you were trying to go underwater, if you're going underwater, that's changing the medium. So you can actually change the speed of sound underwater just by changing that medium there. Same thing always happens if you are kind of curious and want to try this out. You can take a piece of rope, all right, stretch a piece of rope. If you have it very loose, the wave goes kind of slow. You tighten it up, wave goes a little faster. Same thing happens when you're looking at a guitar. Change the medium is where you're changing the tightness, the tautness of the strings itself, and that's going to change the speed of it, and eventually it actually changes the sound. But whatever the medium is, the speed, wavelength, and frequency of this wave are going to be related. And the way that they're related is in this special relationship I'm going to show you right here. All right, so the velocity, the wave speed, which is going to be our v, right here. So the velocity is always going to equal this funky little symbol here is the Greek letter lambda. It means wavelength, and f, the fancy f, means frequency. So wavelength times the frequency of the wave equals your wave speed. So let's say we have an example right here. Let's say the wavelength is 1 meter on these waves. And we know between here and here they are 1 meter. And we know that the speed, or we know the frequency of it, is that one of these wavelengths passes by this post every single second. So that would mean the frequency is 1 hertz. All right. So then I would go ahead, I would multiply my wavelength of 1 meter. Oh, this is going to be pretty awful looking. There we go, 1 meter times 1 hertz. And guess what my speed is? It is now going to be 1 meter a second. All right. That's as simple as this equation gets. Now let's look to an example. Now one of the cool things we can do is, if you remember from the electrical units, we can put this equation into a nice little triangle where we have the wave speed or velocity on top, frequency on bottom, and the wavelength right over here. So that means if we have the frequency and the wavelength, we just multiply them because they're right next to each other. If I have the velocity, that wave speed, and the frequency, I divide them. So I do the wave speed divided by frequency. And also vice versa, if I have the wave speed and the wavelength, I just do wave speed divided by wavelength, and I'm going to get my frequency. All right, so let's do this example right here. We know the most annoying sound in the world has a frequency of 10,343 hertz. All right, I don't know why it's that frequency, but it just is. The speed of sound we know at sea level, traditionally 20 degrees Celsius, is going to be about 340 meters a second. So I want to know what the wavelength is. So first thing I'm going to do is I'm going to go through, I'm going to list what I know. I know my velocity is 340 meters a second. I know my frequency is 10,343 hertz. I don't know my wavelength. So I'm going to look at my equation. I'm going to look at this and I'm like, okay, this doesn't really work here because I already know my velocity. But if I look at my little triangle over here, I know that my wavelength is going to equal my velocity over frequency because those are the two I have. I take that, go to my next step, now I fill them in. 340 meters a second is my wave speed. My frequency is 10,343 hertz. I go through and now I do that math. Boom. my wavelength is 0.0329 meters. So again, our wavelength is always going to be in meters. Our frequency is always going to be in hertz. And if you remember from the other day, hertz means how many times something happens a second. All right, in meters a second, hopefully you guys know that from the beginning units. That is just a distance divided by time, what velocity generally is. Let's go to another question. So we got waves at the beach, and on a certain day they have a wavelength of 80 meters. That means there's a stretch of 80 meters between each one of the waves that are coming in. And they're also occurring with a frequency of 0.2 hertz. That means basically about every 5 seconds you're going to have a wave hit you, which is pretty typical. All right, so I want to know what the speed of the waves are at the beach this day. So I go ahead, I list out what I know. I do not know the velocity. I don't know that wave speed yet. I do know the frequency is 0.2 hertz, and I do know my wavelength is 80 meters. So now I go ahead, I take a look at this. This equation actually is going to work out pretty well because I know the frequency, I know the wavelength, so I'm just going to multiply these two. All right, then I go ahead, I plug them in. 0.2 hertz times 80 meters. All right, we're going to end up with a velocity. And velocity, if you guys remember, is going to be measured in meters per second. So here we go, boom, multiply them. Our wave speeds on this day would be 16 meters per second. All right, so these equations should be pretty straightforward. I'll go through, there'll be a couple of questions that you guys are going to go through. I'm going to check them, just make sure they're right. Please make sure, write down as much of the work that you can. I know it's kind of tough when you're doing it online, but I just want to make sure that you're doing it, understand what's going on there and just not just putting in numbers. Feel free to email me too if you have any questions. Last thing I'm going to talk about before I go on, wavelength and frequency. What they do is they vary inversely. All right. So what that means, if I have, say, like sound, I know that my sound is always going to be 340 at this level. So because the way the equation is set up with velocity equaling frequency times wavelength, what this means is that if my wavelength changes, let's say my wavelength gets shorter, all right, we're going down, we get shorter, guess what the frequency has to do in order to still equal that 340? It actually has to start going up. So you'll notice down here, 528 is the highest out of these values, but over here, this one's the lowest. All right, so they're inversely proportional because as one is getting smaller, the other gets larger. All righty. If you have any questions, email me. Otherwise, have a great day.